Hey team, welcome to the numbers game. I'm Coach T, and in this tutorial, we'll be finding the polar curve of a complex number. Let's get started. Complex numbers are formatted as a plus bi, and this expression is set equal to z. And graphing a complex number would require that we plot a on our real axis and b on our imaginary axis. And these two come together to give us the point AB. Now we want to find the polar curve of our complex number. So we need to factor in r, the distance from the origin, and theta, the angle between the x-axis and r. In our graph, this line represents r, and this angle is theta. So let's take a look at how to turn our complex number into a polar equation. Now take note of the fact that a equals r times cosine theta and b equals r times sine theta. So if we plug this into z equals a plus bi, our complex number, we get z equals r times cosine theta plus r times sine theta I. Now we can factor out r to get z equals r times cosine theta plus I sine theta. So when we find the polar curve of our complex number, this is the form that our final answer should be in. Okay, so now that we know a little bit more about polar curves of complex numbers, let's take a look at an example. All right, so this is our example, and our example says, let z equal 13 minus 13i, find the polar curve. Let's start by graphing this. On our real axis, we have 13. And then on our imaginary axis, we have negative 13. Remember that we're trying to convert our complex number, which is in the form of z equals a plus bi, to a polar equation. So we need to find r and theta. So we're going to start by finding r. Keep in mind that we're basically looking at a triangle here, so we can use Pythagorean theorem, which tells us that a squared plus b squared equals r squared. Or in other words, r equals the square root of a squared plus b squared. So for us, we have r equals the square root of a squared, 13 squared, plus b squared, which is negative 13 squared. This gives us the square root of 338, which simplifies to 13 square root 2. Okay, perfect. So we were able to find r, and now we just need to find theta. I'm going to use SOHCAHTOA to do this. SOHCAHTOA is sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now I'm using SOHCAHTOA because we have a triangle here, and it's pretty easy to find cosine theta and sine theta. So with that being said, sine theta is opposite over hypotenuse. For us, that's a over r. Our side a is opposite theta, and r is our hypotenuse here. And cosine of theta is adjacent over hypotenuse. For us, that is our side b over r. And plugging in, we have a sine theta of 13 over 13 square root of 2. And cosine theta equals negative 13 over 13 square root 2. Now, with some basic algebra, we see that 13 over 13 square root of 2 simplifies to square root of 2 over 2. So sine theta equals the square root of 2 over 2. And cosine theta simplifies to negative square root of 2 over 2. When sine of theta equals square root of 2 over 2 and cosine theta equals negative square root of 2 over 2, what is theta? Theta equals 7 pi over 4. So we've got our r and theta, and now we just need to write our polar equation. That is z equals r, which we found as 13 square root of 2, time cosine of our theta, which is 7 pi over 4, plus I sine of our theta, 7 pi over 4. And there you have it. That's how you find the polar curve of a complex number. I'm also going to leave you guys with an exercise to do on your own. And here is the exercise. It says let z equal 4 square root of 3 plus 4i. Find the polar curve. I'm going to leave the answer to this in the description box, but don't take a peek before you get your own answer. When you do get your answer, drop it down in the comments below. And if you have any questions about how to solve this, of course, I'll jump down there and help you all through it. I hope this video was helpful for you all. If it was, give it a thumbs up, like the video, and subscribe to the channel for more math tutorials. I'm Coach T, and thanks for watching The Numbers Game.